this is the second part of my invention. It shows how you can use the two devices who are going to be communicating with each other by exchanging QR codes. And this will allow bidirectional communication between the two networks without actually using a network. We will be retrieving a file from this computer in the SCADA network. It is actually an image file via a web browser that is going to make a request across the airgap SCADA system. So here's a web browser which will be making a request, an HTTP request that will be converted into a QR code, which is going to be received by the device in the SCADA network, which will in turn retrieve the file and convert it into a series of QR codes. Again, this is very low quality hardware, so the conversion and encoding is going to be very, very slow. The QR codes are going to be received by the camera on the device on the internal corporate network, which will reassemble the data in the QR codes, and it will at some point display the image on the computer. And here it is. It was about 7 or 8 QR codes. As I said in the previous example, these are Raspberry Pis for lower machines, very low quality, very low speeds, with very, very low resolution displays that can only display about 400 bytes at a time. The data is being compressed and base 64 encoded, which will cause it to be split in several sections, 400 bytes each. Bigger QR codes can display 4K worth of data and can be encoded much, much, much faster than what these Raspberry Pis can do. So the actual speed is going to be in the order of 50 to 100 times better with decent real hardware.